C2, Differentiation, past paper question, January 2008. So here we are given a diagram of a open-topped water tank in the shape of a cuboid, which is made of sheets of metal. So we've got lengths of X here and here, and we have a length of Y here. So we're told that the capacity of the tank is 100 meters cubed. So capacity, that tells us the volume. So for part A, we're asked to show that the area of a meter squared of sheets of metal needed to build the tank is given by this. So that's what we're trying to end up with. So the first thing I'm going to do is use the information given to see that the volume of the tank is 100 meters cubed. So volume, which would be given by x times y, so that's x squared y, is equal to 100. So I can rearrange this to give me y equals 100 over x squared, because as in the previous questions, at some point we're going to have to eliminate a y so that then we can differentiate. So now, surface area of the tank, that could be found by doing, well, we've got x times x for the two end pieces, so that's 2x squared. So that's for the ends. And then we have 3 x times y's, because we've got one for the back, one for the base, and one for this side. That's why it's really important to read the question, because we're told that this is an open-topped water tank, which means that we do not have a sheet of metal on the top. So we just have 3 x, y. We only have 3 sides that have an area of x, y. So that means that we have A equals 2x squared plus 3xy. And now this is where we're going to substitute in the y that we found from rearranging the volume. So if I substitute that in, that'll give me A equals 2x squared plus 3x times 100 over x squared and if I expand that bracket, I get A equals 2x squared plus 300 over x, because that x cancels with that squared there. So we've ended up with what we needed for part A. So for part B, we need to use calculus to find the values of x where A is stationary. So for part B, we know that the stationary points will be at dA by dx equals to 0. So I'm going to use this and differentiate what I have here for the area. So I'm going to start off with A equals 2x squared plus 300 x to the minus 1. Okay, so now I can differentiate that. So dA by dx will be equal to 4x minus 300 x to the minus 2. Just multiplying by the power and then reducing the power by 1. So I want where 4x minus 300 x to the minus 2 is equal to 0. So I'm going to take my minus 300 x to the minus 2 over to the other side. So that's 4x equals 300 over x squared, just taking the x to the minus 2 on the bottom. And then I'm going to move my x squared up here and my 4 down here. So that gives me x cubed equals 300 over 4, which equals 75. So x will be equal to the cube root of 75. And if you put that into your calculator, we come out with 4.22. Okay, so when x equals 4.22, we have a stationary point. And because we are only asked to find the value of x for the stationary point, we've finished with part B. So for part C, we're asked to prove that the value at x gives a minimum value of a. So we need to do the second differential. So this is for part C. We need to do the second differential of what we have here. So we need to do d2a by dx squared. So multiply by the power would give me 4, and reduce the power by 1 means that the x disappears, and then multiply by the power would give me plus 600 x to the minus 3 once we reduce the power by 1. So we want to substitute in x equals the cube root of 75. So that would give me 4 plus 600 over 75, which gives me 12. So because 12 is greater than 0, we have found a minimum at x equals 4.22, or the cube root of 75. So we've done what it asked for in part C, we've proved that it's a minimum. Now for part D, we have to calculate the minimum area of sheet metal needed to make the tank. So we know what our x is, we need to find out what area that gives us. So we know that the area can be found by using this, and we have our x, so I'm just going to substitute that into the area. So D, we're starting off with A equals 300 over x plus 2x squared. So I'm going to substitute in x equals the cube root of 75. So that would give me 300 over the cube root of 75 plus 2 lots of the cube root of 75 squared. And if I put that into my calculator, I get 106.7067991. So I'm going to give that to a set number of decimal places, 106.707 meters squared, given to 3 decimal places. So we've figured out what the minimum surface area of the sheets of metal will be to make the tank that holds 100 meters cubed of water.